How's it going, everybody? In this particular video, we're going to cover a little more depth on how we can administrate or administer the VLAN network, and some of the ways that we can modify and make our jobs a little easier when it comes to actually setting this stuff up. So, in normal VLAN administration, in order for devices to be in the same broadcast domain, VLAN numbers must be consistent and interswitch links must be running trunking, and they also must be forwarding the layer 2 information. Now, when we get a little farther into this, you'll see what I mean by where we can pick and choose which switches get which VLANs and some options there are for that. As layer 2 network size grows, managing VLAN numbers and trunk allowed lists involves large administrative overhead. That's why we covered it now instead of later. I wanted to show you how to do it manually first, and then how to do it more of a automatically later on. However, if you're not running Cisco devices, you will not be able to do a VTP pruning. You will have to manually modify your trunks unless you're using some vendor that supports a VTP equivalent technology. I don't know any other vendors that do something similar to that. Juniper, F5, Brocade, they may. I'm not aware of it. But the idea is, if you have a situation where you need to modify an allowed list, you need to do that at the trunk level, which means you have to get onto the switch and manually define it. We'll talk about VTP and how we can how this allows for scalability. It's Cisco proprietary. It's trunking, so it's a replication. So it advertises the addition, removal, and modification of VLAN properties, name, numbers, etc. Negotiates trunking allowed lists, VTP pruning. It does not affect the actual VLAN assignments. That still needs to be manually assigned. However, VTP pruning, when we get to it, is a way for you to pick and choose how VLANs are, or how much VLAN replication is actually done. What VTP does is it exchanges information between switches. They must be in the same domain. So this is where the VTP domain comes into play. The mode controls who can advertise new modified information. There are three types: server, client, and transparent. Server obviously advertises information and requests updates from clients. Clients can only take information that servers and transparent mode switches advertise down to them. Transparent mode, they don't take information from the server. They will forward information down to either other servers or clients, and they do not participate in the updating of the VLAN database. The revision number is a sequence number to ensure consistent databases. Higher revision number indicates newer database. The transparent mode devices always have a revision number of 0, and if a server, if you configure it as a server, which comes by default on Cisco devices, will automatically have a revision number of 0 to start with, and for every change, doesn't matter what it is, the number will increment by 1. So what ends up happening is, if a server has a revision number of 10 and a client has a revision number of 5, then the client will automatically update its information to the current revision number of 10, and it will take whatever information is given to it by the server. If a client device reloads and comes back online, it will send a request packet up to the server for an update from the server, and then the server will replicate that information down to the switch. That is in client mode. The domain itself, VTP name, domain name controls which devices can exchange VTP advertisements. It does not define the actual broadcast domain. So it's configured with VTP domain. By default, there is no name. It inherits whatever the first name that it hears. The server mode is the default mode. It allows addition, deletion, and modification of VLAN information. Changes on server overwrite the rest of the domain. The client mode cannot add or remove or modify information. It listens for advertisements originated by the server, installs them, and passes them on. It can also request an update from the server. Typically, what ends up happening with that is it would actually wait for the VTP update timer, and then take whatever update it gets. And then the transparent mode, it keeps a separate VTP database from the rest of the domain. Does not originate advertisements. It transparently passes received advertisements without installing them, needed for applications like private VLANs, which we'll talk about at the end, which you can see down here. VTP security, you can implement a password, which is where this guy comes into play, and then that will ensure that VTP advertisements are secure and not being modified. And we'll get into VTP now. So we'll go to switch 1. Actually, all 4 switches will participate in this, and we'll get into that. So switch 1 will be the server, and 2, 3, and 4 will be clients. So what we're going to do is we're going to drop this guy down, pull up this guy, and we're going to go to switch 1. We're going to do config t VTP mode server. It should already be in server mode. We're going to say VTP password is going to be actually domain is going to be dbminc, and we're going to have an issue now. We'll have to do this for the rest of the network. And we'll type in VTP pass is going to be widgets, and so that is that. So now what ends up happening is if I had multiple console cables or windows available, I would show you this. But what ends up happening is now VTP is being sent down to the rest of the network. So what I'm going to do is on this guy, I'm going to say VLAN 100. I'm going to say name is lobby. And I'm going to say, and so switch 1, we're going to put that VLAN in that place, switch 2 and switch 4 respectively. I'm also going to say VLAN 200. I'm going to say name is conference. Room. And VLAN 300 name is cafeteria. So I'm going to drop down now. I'm going to do show VLAN. We have these additional VLANs created. I'm going to type in show VTP status. Right now we have 15 existing VLANs, and right now we're going to do I'm going to go to global config and type in interface range fast season of 0/10 through 11, the switch port mode access, switch port access VLAN 100. Show VLAN, just make sure everything took. And everything, wait a minute. Bash 0/1 is in 10. Ah, VLAN 10. I don't know how that happened, but it did. Huh. Somehow it's in that VLAN as well, actually. Interesting. Alright, cool. So what we're going to do is we're going to jump down to switch 2. And we're going to do show VLAN. And we're not getting those updates. Any idea why? Well, I can tell you. Config T, we're going to do VTP mode client. And VTP password is widgets. And so now we're going to drop down show VLAN. We may have gotten, okay, that's what I thought. We have to actually put it in the same domain. config t. VTP domain is dbminc. There we go. Now we got it. And so on switch 2, we're going to go config t, interface, range, fast 0/10 through 11. I would say switch port, access VLAN 100, or 200. And there they are. Cool. So now we're going to go to switch 3. And what ends up happening is by changing the domain and the password, it automatically replicates that information down. So that's the whole idea of VTP, is to replicate VLAN information dynamically. So what we're going to do is config. We're going to do a show VTP status here, and we're Cisco. We have 53 revision number, so we've made 53 changes at the minimum. So we're going to go config t. We're going to say VTP domain is going to be dbminc, and we're going to do a do show VLAN. And it hasn't replicated down because we haven't changed the password to widgets. Did it change now? It did not. Why not? Oh, VTP mode client. And there they are. And then we're going to go to switch 4. We're going to ping 192.168.1.64. We can ping it. We're going to console over to that guy and add him into the mix. If I'm moving a little fast for you, I apologize because I do this stuff on a pretty regular basis. We're going to do a config t. We're typing interface range, fast season of 0/10 through 11. I knew that was going to happen. Switch port mode access, switch port access VLAN 300. Huh. Oh, that's right. Config t, VTP mode client, VTP domain is VTP domain is dbminc. VTP password is widgets. Show VLAN, and there's all of our information, folks. So there we have it. Implement the new VTP policy and VLAN assignments per the request. And we've done that, so we know that VTP is working. No, it's not. Oh, huh, that's actually a really good point. What you're seeing here. What basically happened is, and I don't have pruning in that I believe. Let me jump over to switch 1. I don't believe we have pruning going. But if we do, show VTP status. It's disabled. How come it didn't go down? Unless something else is, normally what you would see is as soon as you would put a port into a VLAN, then the port, because right now we're not getting 100 or we're not getting 200. We put ports, actually let's do this. Let's go config t, and I want to see if debug VTP, is that an option? VTP? Debug, what are my options here? VQPC, whatever the heck that is. Let's debug .1q, debug domain. That's DNS. What are my options here? I want to debug, because I think Wait, no, okay, let me explain this real quick, just so you guys have an idea of what I'm talking about. So I'm not rambling. Let's just maximize this out. Okay, so switch 1 right here. He is the server. These guys are all clients, right? So right now we're getting 300 because we have 2 ports in it. So normally what would end up happening is if a switch is not doesn't have ports into VLAN, VTP pruning would prevent VTP updates from being sent down to this device. So now if all of a sudden we put 1 port into this VLAN that we said add 2 ports to VLAN 100 here. Let's do that. Let's exit out of here and do show VLAN. Did it replicate all of them down? It did. So it makes me wonder. Show interface trunk. Is it forwarding those VLANs? Sure is. Okay. The only way for me to test this would be to go to switch 1, create a VLAN in that IP address range, and then ping between switch 1 and switch 4. But see if it's actually forwarding traffic. But normally what would end up happening is as you add a port to a trunk or to a VLAN that doesn't actually exist on here, VTP would actually send a request up to the server and say, hey, I need that VLAN. So he would send that VLAN information down to switch 3, and then that trunk or that VLAN would be allowed across the trunk. So it's just weird that it's not showing up for these guys. Now if I go to switch 2, is it showing up for switch 2? Of course I grab every console cable but the one I want. Show VLAN. Showing up for them. Even the ones that aren't configured. Okay. Well, I'm not going to worry about that too much because it is an older switch. It could just be whatever. I don't know. But that is the idea. So now that that's working, the next video we'll talk about VTP pruning and how that works and how it'll actually remove VLAN information from the devices because there won't be any receiving any requests, or at least that's the idea. So I hope this has been informative for you, and I'd like to thank you for viewing.